Welcome back. Today we're looking at exponential functions. We've previously seen linear functions and quadratics. Remember, quadratics have been the main focal point of Math 10. Linear and exponential functions we saw back in Math 9. So while this is partially review, we're still going to be taking a look at a few new things. Same standard as before, taking a look at our exponential functions, expressing them symbolically, showing key features of the graph. An exponential function has a general J shape. As we can see here, this is a positive increasing function. It's going in a general trend like so, with a function equation, f of x equals a times b to the x power. We'll go through and talk about which one is a and which one is b, but in general, b is how quickly the function is increasing or decreasing. A is going to be our initial point. So, we're going to be going through 3 examples today, looking at the 3 different ways to solve these problems. As we can see here in our first example, we actually have the function already given to us. So our main objective here is simply to input numbers into our x value and then come up with our y values, creating a graph and making a domain and range. So for this first example, we simply need to take and plug in our x values. So here, our first value is -2. We plug it in for x, and we end up getting 0.75. We plug in -1, so 3 times 2 to the negative first, we get 1.5. Continuing on with our calculator, we get that our next value is 3, the following value is 6, and finally we get 12. Notice that each y value is actually being doubled from the one previous. We're going to see that that's what that value actually does. It tells us how quickly something is increasing or decreasing. The value up here says 2, which means it's doubling each and every time. So go ahead and plot these points on the graph. -1.15 would be there, 0, 3, 1, 6, and 2, 12, which we'll estimate up there. And as you can see, we have our J-shaped graph like this. This is our exponential function, and we can go into our domain and range at this point. So for the domain, we can plug in any x value we want. So for the domain, it's going to be all real numbers. That symbol means all real numbers. For the range, though, we can see that this is going up forever. So it's going to be some sort of a maximum value. It's going to be greater than or equal to something. But if we think about it, the y values are getting smaller and smaller as you continue going that direction. But it's actually never going to get any less than 0. And in fact, it can't ever equal 0. Leading us to say that our range is y is greater than 0. So now we're going to go ahead and take a look at the next example, which involves us looking at a graph, and coming up with the equation of this graph. Now, remember, in order to come up with an exponential equation, we have to know the form. Y equals a times b to the x power. A is your initial value. So another way to think about this is, what is our y-intercept? we take a look at the graph, and our y-intercept is actually at 2, meaning that in our function, a is 2. For the b value, we're looking up exactly how quickly is this increasing. So, take a look at our points. We're going from 2 to 6 to 18. What are we multiplying each time? To get from 2 to 6, 6 to 18, we're multiplying by 3. Meaning, the actual equation of this graph gives us y equals 2 times 3 to the x power. So again, your a value is the y-intercept, the b value is the factor by increasing or decreasing. So in this case, it was tripling in size each time. For our last example, we're doing the same thing, only instead of coming from the graph, we're creating the equation from the table. However, we solve this exactly the same way. We need to come up with an a and a b because they fill up the equation. They're the only two values you need. Remember, your a is the y-intercept. So, what's the y value when x is 0? And we get that the y-intercept is 3. For the b value, we're taking a look and saying, what are we multiplying by each value in the y's? So to get from 3 to 6, and 6 to 12, and 12 to 24, we're simply multiplying by 2 each time, telling me that my b is 2. Finally, we input our a and b into the equation to come up with y equals 3 times 2 to the x power as our final answer.